Hello, my name is Hajime Sugiyama from Mitsubishi Electric. I'm an industrial IoT evangelist, and today, as a part of my latest Industry IoT Trends for Everybody, I'd like to talk about maintenance of the future, manufacturing with after COVID-19. As factory life wasn't tough enough, we've had disasters, we've had trade wars, but with the corona, another tough challenge is in front of us. But we have to try our best. And I think we've learned a lot through this crisis, and we're still learning every day when we're doing manufacturing. What we've learned about the supply chain is that, for instance, multi-source, multi-location is so important, and this time we found out that, even 2 locations is not enough. This time the entire supply chain stopped throughout the world, so you have to be really flexible in order to make sure you can procure parts during this kind of crisis. The other thing was about engineering. So, there's no overseas trips allowed right now, so it's very crucial to be able to remote engineer stuff and also do remote commissioning when you have a new factory line to start up. In the past, we just go over, but now you have to kind of manage that through the web. And finally, manufacturing. I'm going to talk about the other 2 topics in another presentation someday, but today I really want to focus on what's happening to the factory floor because of COVID. Okay, what's changed inside the factory? I think there's main 2 points that have changed. The first thing is we are going to need to do social distancing and contactless. And the other things is shift management, meaning we have to manage the factory with less people. First, about social distancing and contactless. I think you can imagine, every day in the restaurant you say take your social distance, but it's the same in the factory. We can't afford to have 2 people close together. They have to take their distance 2 meters away. And the other thing is contactless, meaning in a normal factory you would have one product flowing out the line, but in this case, this kind of product may be the carrier that will infect everybody throughout the factory line. So you want to reduce this contact as much as possible. In order to accomplish this, what do you need? I think there's a couple of things. Of course, do more machining or put more robots inside your factory line is an obvious choice. If the machines are doing the work and humans are not, then you reduce the risk of having infections. The other thing is also sensing, inspection. In the previous days, you would do it by eye, using a hand, touching the product. But we have all this cool technology with image recognition and vision inspection. So why not use this technology more in the factory to avoid contact? And the other thing is voice and face recognition. There's a lot of buttons in the factory. You're pushing a screen, you're pushing a button, but this is also some risk to become contagious. So in that case, if you can use your voice to control things, why not? The other aspect is shift management, meaning less people. We're doing this also in our factory. It's very risky to have one shift with all the crucial people for the production line working at the same time, because if you're unlucky and somebody gets infected, you have the risk of shutting the whole factory down, and there's nobody who knows how to operate their line. So what we're doing in our factories is we're dividing up the people in shifts and making sure on these 2 shifts that there are people that know how to keep this production line running. If we can do that, even if unluckily one shift was effective, we still have the other shift be able to continue production, so we'll still be operational. So think about this. If you think about shift management, it means 2 things. It means, one, that you're going to have to manage with less people, which means you're going to need more automation. And the other thing is you're going to have to grow the knowledge level of the less people, because there's less people to run the line, meaning they're going to have to do more multitasking. And in order to do multitasking, you have to teach them first. So you have to educate them to learn some of the tasks or some of the operations that they didn't know before. But it's really hard to do education now, because education is standing next by the worker and teaching how to do things, but that's not obeying your social distancing. So I think we're going to be seeing more AR and VR tools to make education easier. The one more thing is remote maintenance. Of course, you can't transfer all the skills, so there will be the time where you're off shift and a big problem happens in the production line, where you don't have the right staff because you're separated into two. In that case, it's going to be vital for him to remotely access the factory and see what's going on and get advice how to let him send advice to the staff working on the factory floor to fix things. And this is the same with overseas trips. In the past, big problem. You will have to. You'd sometimes even send an engineer over to the factory overseas, but now you can't do that because he's going to be confined for maybe 2 weeks before he can get into the factory. So that's why remote maintenance is such crucial. The next step and the ideal step is making a smart factory where you don't need the people to do the maintenance work. The AI and the cloud figures everything out and does predictive maintenance for you. So you can work, it's easier to work with less people. And today I'm going to talk a lot about predictive maintenance, which I think is very, very important to find problems that might occur in your factory. Your nightmare starts here. It's the little things that start a big problem in the factory. For instance, there's a gearbox here, but this red gear breaks and the entire factory stops, and it's usually a disaster. But the problem was very, very, very small. I'm going to tell you a kind of story, but I'm going to go backwards in time. Right now, there's a guy who's holding his head. It's because the factory line stopped. A machine broke down. He tried to find some spare parts in order to fix the machine, but the supplier says, oh, hard luck, this is a special part, so you're going to have to wait 2 months. So he has to wait 2 months, and the production line is going to stop for 2 months, so it's actually a disaster, and that's why he's holding his head. But if you look what happened before this, minutes ago, of course, minutes before, some smoke came up, and something was wrong, and they find out there's a problem. But if you look at days before, actually this machine was gaining heat, it was getting a little bit hotter. If you touch the machine, it was a little hot, but nobody found out and decided to do anything about this. Before that, weeks ago, this machine was actually putting out a very, very low sound that people, ear couldn't hear. But it's because, a kind of screw was getting loose. And then the plate that was, the panel was getting loose and wobbling, so that's why they had this strange noise. And if you go before that, actually there's a lot of vibration months ago. But, nobody was paying attention. It was very, very small, so nobody noticed it. But, the screw was getting loose over here. What I'm trying to say, there was a change in the condition months ago, and if this guy was able to detect that before it happened, he'd be able to do something. He'd be able to say, okay, this is a bad trend, so just to be safe, I should probably order some spare parts for this before that. And that way, if something happens, I can exchange the part. And if he had done that, he'd have the spare part in time, and he would be able to avoid this massive shutdown that he actually has. So finding out this kind of change in condition and vibration beforehand is very, very important. And that's what we're talking about when we talk about predictive maintenance. For maintenance, you need data. So what you're looking at the manufacturing data, what you're producing, the time. Also, very important is the machine process data, the temperature of the machine, the pressure, the voltage of the motors, the current, those kind of data. Also, environmental data is very, very important, especially in predictive maintenance. We're talking about temperature data, humidity data, atmospheric pressures, and also you need some kind of maintenance conditioning monitoring data, like models and mechanisms to kind of absorb this data and figure out when it's going to break. So this maintenance is about collecting data and utilizing data. But your final goal is you want to install a 24-hour doctor. What I mean a 24-hour doctor is usually when you see a doctor, he says, your blood pressure is going up or you have too much blood sugar. Every 3 months you go, but it's like a normal checkup. But sometimes this every 3 months is too late in a factory. You need to find out if something's going wrong the minute it's going wrong. In order to do that, you need the best way to do it is have a doctor always looking and checking what your health is doing. And that's what we're talking about when we talk about predictive maintenance systems. Installing a 24-hour doctor that is constantly monitoring the system and health of your factory. But in order to do that, you can't automatically make a predictive maintenance system. It always starts with collecting data. But because if you don't have any data, you can't do any maintenance, you can't analyze this, you can't visualize this. So always you need to start with sensing, putting sensors on, collecting the data. Later, then you can visualize this data and put them into charts. And if you can put them into charts, then you can decide, okay, when is something going wrong, and if something's going wrong, make sure that somebody knows about it, sending out an alert. And the ideal goal in the future is to be able to self-optimize. So, for instance, if you see the temperature is going up, then you automatically make a program in those cases to turn up the fan or turn up the air conditioning unit. But it always starts with data. So without data, you can't do anything. Also important to know is predictive maintenance in a factory is a step-by-step process. You don't start with the whole factory. In order to do predictive maintenance for the whole factory, you need to start with small things like a cell. When you're able to do predictive maintenance for the specific cell, then you move on to the next machine. You move on to the next machine. And if you are able to do these predictive maintenance for these individual cells, then you will be able to do it as an entire production line. So first things come first. You're dreaming big, but actually you're starting small. And then after you do the factory line, then you can move to another factory line. And then finally, you'll be able to do predictive maintenance as a whole for your factory. But everything starts with the all individual machines. So it looks a little complex, but depending on the way you can do it, there's simple ways to do predictive maintenance. And I want to show you some examples of how simple it can be. I'm going to start with the example of a wastewater treatment plant in Germany, in a small town in Germany. So let's go into the details. This is the application. So it's moving wastewater from the bottom side to the upper side. And it does this by using these three, what we call Archimedes screw pumps. And these are moving by using a gearbox and a motor, so rotating. The issue with this application is this is an unmanned plant, meaning there's no person that's working in this facility, and the screws break between 1 year and 3 years. So you can't even ever predict when it's going to break. The reason is when it breaks depends on how much people are throwing garbage into the wastewater. So if a lot of people throw a lot of garbage in the wastewater, that means the load on the screws will become bigger, and it will break faster, for instance, in 1 year. On the other hand, if everybody's not throwing away a lot of garbage, the water is clean, that means the load is less, so it might last for 3 years, but you never know. This depends on everyday life. So what they wanted to do is they were doing periodic maintenance, meaning every 6 months they go and then check to see if everything is okay, and then they go back. But sometimes they got an alarm that it's suddenly breaking and everything's overflowing, do something. And they wanted to fix that and be able to predict, find out when it would break, and to be able to fix things before the actual trouble happened. So what they did is they installed a predictive maintenance system, a 24-hour doctor. It's very simple. I mean, when you think about predictive maintenance, a lot of people think you have to put sensors all over the place. But if you look at this specific application, usually always the gearbox breaks, like 95% of the time, because the screws are connected to the gearbox, and this has the most load. If you look at the gearbox, it's connected to a motor that's rotating the gearbox. And what we did in this case was we put a smart vibration sensor on the motor, because if it felt more vibration, then we know something's happening, something's going wrong in the gearbox, and then we could send out alarms. So it's a very, very simple system. As I said, we just have 3 smart vibration sensors placed on the motors on the Archimedes screw pumps, connected to a PLC, and then remotely we connect this to the central maintenance center. So what the benefit of this is, first of all, if you wait till the gearbox breaks, a new gearbox costs about 5,500 euro. On the other hand, if you can fix the gearbox before it breaks, then an overhaul costs only 1,000 euro. So you save 4,500 euro just by doing this. The other obvious benefit is you don't have any complaints from the city if something goes wrong, and it's not an emergency to handle these kind of situations. So the cost of this was roughly about 8,000 euro, meaning that 2 gearbox failures is about 11,000 euro. So if you think about that, 2 breakdowns, and then you've already saved the condition monitoring system you've involved. So the ROI is very, very simple and achievable. And it's a very, very simple application, as you see. And we were able to develop this with the partners, with Schaeffler, with a system integrator, and we did the remote connectivity with Ewan and HMS. And luckily, it worked. I mean, 4 months after the installation, we found you got an alarm that the vibration patterns was not so good. It was different, and we went and we found the gear wheel defect. So it's a very, very simple solution, but very, very effective, and you also get the ROI. Next, I want to talk about maintenance on the edge. Lots of people have image of doing these kind of predictive maintenance in the cloud, but in reality, you have no time to talk to the cloud when you're doing predictive maintenance. Think about a smartwatch where you're monitoring your heartbeat. If something goes wrong with your heartbeat, then you immediately have to call an ambulance, and you have no time to doing the analysis. It's a split-second decision you have. And that's exactly what the factory is. We're moving in not seconds, not days, not minutes. We're moving in the millisecond world and the nanosecond world with processing and all this precise information. And if you miss, if you're a split second late in reacting, you're going to damage a very, very expensive machine or a very, very expensive part that you're producing. So that's why the timely reaction is so important for predictive maintenance in manufacturing. Are you ready to catch the right moment? And if you look at these waves of quality data, they're moving in milliseconds. So as you can see, and you have to find this little distortion in these waves on the millisecond level, and you're never going to be able to do that if you're communicating cloud. Everything this has to be on the factory floor with an edge computer. I have another YouTube video about edge computing, so if you're interested, you can go over here and see why edge computing is so important for the factory floor. Okay, so we put predictive maintenance on one machine. We're monitoring the motor, vibration on the motor. But the issue is that we're so interconnected right now in our factories. Even if this machine, you can predict something and predict a break, you have to think before what happens in the process and what happens afterwards. Because if this machine is going to break and you're going to have to do maintenance on this, that means you're going to have to stop all the manufacturing processes before this, and the other manufacturing process after this are going to be stopped as well. You have to think, okay, this person that's managing the machine has nothing to do, so maybe I should put him on another task. And you have to think about the parts that are incoming from your suppliers. Okay, maybe because this is we have to fix this machine for 2 days, then you have to say, okay, supplier, wait 2 days, and we don't need any product then. And this was in the past done by your experienced factory staff. They're smart, they have experience, so they know who to call, what to do. But it's going to become more and more complex in the factory because, as you know, right now the delivery chain and supply chain are so interconnected, and also our engineering chains are connected as well. So managing what happens here has an impact on over here is very, very difficult to manage with the human mind. And that's why I think AI will have a more bigger role in the future, because AI has the capability of figuring out what impacts what when something goes wrong. It's just a sample application that I have more detail in my SARTs for robots presentation, but we're monitoring a robot over here with an edge computer, and in this case we're talking to the IBM Watson AI, figuring out when something's going to go wrong and what to do with it. So this is the actual maintenance screen, so it's detecting what's going wrong. Okay, we have a robot that's going to fail, and then in the future, I think it's going to be like this: a chatbot box opens, and we're going to talk to the AI, and the AI is going to tell you exactly what to do. In this case, he's saying, okay, there's a current value, there's a bad waveform in this robot, so these are your maintenance options. And it's going to say this thing, and you're going to check one, and it's going to tell you, okay, we have these parts in stock, so it's okay to do maintenance, or we don't have it, so I'm going to go to the SCM system and order it for you. Is that okay? So it's going to be easy, because the AI is going to decide everything for you and tell you the right options, adjusting your maintenance schedule. So I hope this technology becomes more and more refined. And at the end, you put on your AR glasses, you go to the machine, and it's exactly going to tell you how to repair this machine. It's pretty neat. So, and I have more detail in this explanation form with my AI applied to robots presentation. So if you're interested, you can take a look. I think one of the points is to making life easy for you. I mean, not a lot of people have detailed knowledge about predictive maintenance. So that's why we want, as Mitsubishi Electric, we want to help you with these issues. Like, for instance, as your first steps, it's always visualization and remote maintenance. So we have good SCADA solutions, remote HMI solutions for you. We have a lot of edge computing solutions, so you can pick up the waveforms in the millisecond time frame, and also do simple analytics with IPCs and real-time data analyzer software as well. We have solution packages, so you don't have to do a lot of programming or making screens by yourself, vibration sensor solutions working with partners. And at the end, one of our goals is, as Mitsubishi Electric, is to embed these kind of predictive maintenance functions into the components itself. For instance, if you have a robot, the robot is going to tell you when it's going to break. And I think that's a lot better, because in that case, you don't have to set up your own predictive maintenance solution. All you have to do is buy this robot, and it's going to tell you when it's going to break. And we're putting this kind of functionality in our machines, in our CNCs, in our inverters, and our servo motors as well. So I think this is a good start, for instance, for predictive maintenance. Okay, takeaways, 24-hour doctor, and support in manufacturing to be able to constantly monitor what's going on. Step-by-step process, start with the machine, then expand. Diagnostics on the edge, fast reaction is very, very important. And at the end, please use smart components. Think about smart use with predictive maintenance functionality embedded in it. Okay, if you have some time, look at my other YouTube presentations. We have a lot of interesting, and there's more upcoming. And I hope you enjoyed my presentation. Thank you very much.